Understanding the viscosity of fluids in terms of the way particles inside the fluid behave is really a very good way of looking at the viscosity of all fluids. The first thing that we can understand from this is that fluids have not only a viscous character, that is, they flow over one another, but they can also have an elastic character. If you move the fluid really fast, they don't have time to get out of the way, and then they behave like a solid. A very good example of that is cornstarch. Here's a bowl of cornstarch, and let's try and run the spoon through this bowl of cornstarch. If we run the spoon very slowly, it flows. It's thick, it's very viscous, it's like honey, but the spoon flows. But look what happens if we run the spoon very quickly. If we run it very fast, the fluid jams up. It becomes a solid. So at very short times, cornstarch behaves not like a fluid, but like a solid. We can understand this by this little cartoon that we looked at when we understood the way particles behave to increase the viscosity of a fluid. If we move them very, very rapidly, they jam together. They form a solid. They don't have enough time to move over one another, and they actually become solid-like. It takes some time for them to relax, some time for them to flow over one another. This time is the relaxation time. It's the time for the particles to move by one another just due to their thermal motion, just due to their natural motion. And when the particles get very concentrated or very sticky, that time takes much longer. And so then you see this solid-like behavior at much longer times, and you can see it. However, in fact, all fluids have exactly the same property. For normal fluids, for simple fluids like water or oil, there are no particles to jam. Instead, it's the molecules themselves that jam. However, because the molecules are moving very fast and they can move around one another very quickly, you have to look at very, very short times in order to see this jamming. Even simple fluids behave like an elastic material if you look at short enough times. At these very, very short times, the molecules jam into each other and can't move by one another. They behave like a solid. In fact, you know this because if you jump into a pool of water from a high enough distance, you feel the pain because the molecules can't move out of the way. That's the difference between a dive and a belly flop. Polymer thickeners behave in exactly the same fashion. They too can form a solid at short times. But in this case, it's the polymers that are trying to move through the fluid, and they can't get out of the way of one another at short times. At short enough times, the polymers behave like a gel. They behave exactly like a solid. The fact that all fluids, be they granules, simple fluids, or polymeric fluids, behave like a solid, behave elastically at very short times, allows us to determine what the viscosity is in a much more fundamental way. The viscosity is just the elasticity of the solid at very short times, times the relaxation time. Now we can understand why different fluids have different viscosities. For a simple fluid, the elasticity is quite large, but the relaxation time is very, very fast. It's very small. As a result, the viscosity is quite low. By contrast, for these polymer thickeners, these modernist thickeners, the polymer network has a relatively low elasticity, but its relaxation time is very slow. The relaxation time is large, and that leads to a very large viscosity.